Hi, so today we're going to be looking at forces and we're going to be looking at the GCSE forces. I'm just going to take the specification, go through the different points and take you through hopefully everything you need to know. So essentially, you've got to split this up. We're going to split this into 3 bits. If you're aiming for a grade 4, what you're looking for is you need to be able to define a force and define what a force is, different type of forces, so recall what forces are. For a grade 5 or 6, you're looking at the difference between a scalar and vector force. And also to go up from grade 6, 7, and then even 8, you're looking at using what we call W equals mg, so looking at the weight. So we're going to take each of those 3 bits and look at them separately. So the first thing you need to know is a definition. So what is a force? So essentially, a force is a push or a pull or a twist. So it's a push or a pull. A pull could be a twist, acting upon an object. Upon an object, let me just put your actual definition, an object as a result of its interaction with another object. Right, let me just mute. Okay. Sorry, Alicia, I need you to mute yourself. All right, so a force is a push or a pull or a twist acting upon an object as a result of its interaction with another object. So let's think about it. If we're writing down onto a paper, that's a push. If I'm typing on a keyboard, again, I'm pushing down. If you've got like a tug, you're pulling in a tug of war or some sort of like game, I guess, that's a pull. You're unscrewing a top, that's a twist. So all of these are types of forces. So a force is a push or pull, it's something that you're doing. So now let's look at the basic idea of the difference between a scalar and a vector. So I know we've done this before, anyone who's joined any of the lessons, but annoyingly this one didn't save. So I just want to make sure we go through it. So a scalar has no direction, but has a size. So it has size, but no direction. So it has magnitude, we call that magnitude. As you can see, I cannot spell magnitude, but no direction. And vectors have both. So they both have a direction and a size. So direction and size. So let's think of things. So if I said to you, I'm going at, so let's think of things that have both. So let's think about temperature. Temperature is scalar. It has a size, but we don't really have a direction. Weight, we say, is vector. So weight is a force and it acts downwards, so it has size and direction. Let's think about speed. So if I tell you you're going at 50 miles per hour, I don't know whether you're going straight, whether you're going up, whether you're going down, whether you're going left, you're going right. That's a speed. So speed is scalar. However, the minute I tell you that we're going 50 miles per hour, positive direction, which is straight ahead or to the left, it becomes a velocity, which is a vector. So when I say something is going at a certain speed, I don't necessarily know what direction I'm going in. If I tell you I have gone a certain distance, that only has a magnitude, but we have something called displacement, which also has direction. And the best way to describe the difference, so displacement tends to confuse people. So if you think about it, if, I don't know, there's somebody here, again, I cannot spell or draw, we're going on a journey, they travel around, they go for a really long walk, and they end up back here. So they started there and they ended up there. My distance would be the whole journey that I made. So going all the way around the houses, up and down, all across the roads. Whereas my displacement is just the difference between where I started and where I finished. So if I ended up right back at the same spot I started at, my displacement would actually be 0. So distance is how far I've traveled, it's scalar, displacement is vector. So what about force? Because that's what we're talking about. Is force a vector or a scalar quantity? Well, force is measured in newtons, and it has a size and a direction, because remember we talked about being push, pull, twist. So we're going a certain way. So a force is a vector quantity. Right, so we've got scalar and we've got vector. So let's take some more examples. Let's think about, all right, so we've got somebody, so let's say we've got a man who's walking 10 kilometers north, and then, let's just go simple, then 10 kilometers east. Okay, so we're still in this sort of thinking about vectors. So let's think about what that person's doing. So we're starting here, we're going 10 kilometers north, so I'm going up 10 kilometers. Then I'm going 10 kilometers east. Now, actually, doesn't really walk like that. You've actually done this, right? So you've gone in that diagonal. So what we've got here is this is our displacement vector, because this is the difference between where I started and where I finished. And I could find that length. So using your basic maths, hopefully, and your Pythagoras' theorem, you could do a squared plus b squared equals c squared, and you could find the length of that displacement vector. Should be the square root of 10 squared plus 10 squared, which is 14.1 kilometers. So that's, this is sort of a little bit more extra information. So this is taking up you to the higher bit. Okay, so now all we should have come to, so this is taking you to looking at everything that you need for the foundation and up to grade 6 probably. So now we're going to go to the bit that takes you a little bit further, which is looking at the difference between mass versus weight. Right. Now these are two things you should not get confused. So your mass, so this thing is a measure of how many particles are in your body. So it doesn't matter where you are in your universe, your mass will never change. So your mass is a measure of how many particles in your body. So if you're on the moon, you have the same mass, okay? It doesn't matter where in the universe you are, it does not change. So this doesn't change. However, your weight, this is the measure of the pull of gravity on your body. On your body. On your body. So your weight depends on which planet you're standing on. So you would weigh less on Mercury than you would weigh on Earth, because Mercury is smaller than Earth. So mass is measured in kilograms versus weight, which is measured in newtons. Okay. So if my mass is 10 kilograms, or the mass of something is 10 kilograms, my, so actually not grams, let's do kilograms, that's what it should be, 10 kilograms. My newton, my weight, so if we say gravity is about 10, my weight is 100 newtons. So if this is my mass, this would be my weight. So the connection between mass and weight is mg. So you multiply them together. So we say from a GCSE perspective, Earth's gravitational field strength is 10 Newton kilograms. So we say Earth's gravitational field strength is 10 newtons for every kilogram. So in other words, 1 kilogram mass is pulled downwards by a force of 10 newtons. So the equation that you need to learn is that weight is equal to mass times by the gravitational field strength. So let's think of what those units are. The weight is in newtons, the mass is in kilograms, and this is in newtons per kilograms. So if you see, it cancels the kilograms out and leaves you with newtons. So this is an equation that you need to learn. Now, if you like the triangles and you like your formula triangles, okay, you've got W, M, G. So if you like triangles, and some of you, I quite like them, but it's up to you, you know, whether you use them. And when we use them, you cover up the bit that you want to calculate, and then you can calculate the rest, or you could rearrange it. So let's do a couple of examples, and then this takes us to the end. So what is the weight on Earth? So that's the important thing, because the weight changes on Earth of a book of mass 2 kilograms. Well, we take our formula, W equals mg, the mass is 2 kilograms, G is 10 newtons per kilogram, leaving us with 20 newtons. So that's a nice straightforward one. So whatever mass goes up by, weight will go up by the same ratio. So another thing that you might see, or you might get asked to say the relationship between weight and mass, we say that weight is proportional to mass. So this takes you all the way through to sort of up to your level 7 questions. Level 8 and 9, it gets a little bit trickier, but we start to go a little bit into some of the A-level math stuff. But this should be a good introduction to forces. I hope that's useful. That's a quick 15-16 minute introduction. And I'll be back online in about 5-10 minutes and looking at a math topic.